Hello and welcome to our discussion today about deconstructing the digital Tower of Babel. My name is Bob Hogue and I head up the marketing for RWS Government, Aerospace and Defense, and I'll be your moderator for today's session. All of us on the call today are part of RWS, the world-leading provider of technology-enabled language, content management, and intellectual property services. We support 90 of the top 100 global brands with our portfolio of solutions. Today, we have two senior representatives of our Language Weaver team with us. Bart Muczynski, who is our VP of Solutions Consulting, and Dragos Mutano, who heads up our research and development team. Bart started his career over 20 years ago at a small and relatively unknown company, Trados, which within a span of a few years became synonymous with translation memory and grew to become one of the most popular computer-aided translation platforms in the world. Over the years, Bart has expanded his focus to machine translation and to the practical application of linguistic AI across use cases where multilingual content needs to be generated or comprehended. Bart brings to our conversation today deep experience with working with some of the world's most interesting customers and challenging language-based use cases, including global enterprises and government agencies. Dragos began his professional career in 2007 after finishing his PhD, and joined a little startup called Language Weaver. He began as a research scientist to help achieve the company's mission of creating the best statistical machine translation engines on the planet. Today, after his initial success with Language Weaver, he leads his R&D team as they build both the technology and the products that deliver linguistic AI capabilities, such as machine translation and content insight. And with that, I'll turn it over to you, Bart.
Thank you for the introduction, Bob. Hello, everyone. Welcome to our webinar. My name is Bart Muczynski. Today, Dragos and I are going to talk about the use of machine translation within government. We'll start by asking why machine translation has become so attractive to various agencies and organizations. And we will review the main machine translation use cases and workflows. Then we'll look into various strategies for improving translation outcomes. That'll be things like adaptive machine translation models or providing interfaces for a human-in-the-loop approach. And then finally, we'll briefly review the main technical aspects, including deployment models, scalability, etc. And then we'll switch to a brief live demo of the Language Weaver platform and conclude with a quick Q&A session. Now, in order to understand why machine translation has become so popular within both the enterprise and government world, it's probably best to understand what machine translation is good at. Now, some people would say that MT has not yet achieved human parity when it comes to output quality, although I know some colleagues that would disagree with it, at least within certain parameters. What it can do, without any doubt, however, is it can work very, very fast, orders of magnitude faster than a human translator. Now, if you look at an unaided translator, professional linguist, they can translate about 2,000 words per minute. Per day. A good machine translation system can do this per minute and can scale further to perhaps 200,000 words per minute or more if it needs to. So it can also do this without breaking the bank because it's obviously less expensive than a team of translators. Thus, translating a truly mind-boggling volumes of content has become achievable. For example, machine translation is an attractive option for the rapidly digitizing government services because they need to reach all sorts of target communities to convey information, but also to collect it. public school systems, transportation departments, health programs, tax offices, courts, law enforcement, border and homeland security, trade. There are always tons of documents, forms, questionnaires, updates, alerts, website, chatbots, knowledge bases, all those types of content that were originally developed in English and can now be rapidly translated and published for these constituencies. Then there's also the other end of the spectrum, where the machine translation need is probably even bigger. Countless government agencies, teams, and programs and functions whose main job is to know what's going on, and both at home and abroad. And they do this by watching, listening, reading content that is being produced elsewhere in order to gain actionable insights. That may include foreign publications, social media, but also materials obtained through, let's say, other means. Machine translation becomes a link in all those analytics pipelines. It helps convert the multilingual input into a single language that can be then handled either by automated systems or human experts. It's really very difficult to visualize how much content there is. Some estimates say 2.5 quintillion bytes of data are generated every day. I had to look it up when I first read it. A quintillion is 10 to the power of 18. So Twitter alone is a source of about 500 million tweets every day. So there's simply not enough translators in the world and not enough time to translate everything in the traditional way. So let's have a look at some of the main machine translation use cases first. The first use case or group of use cases is what we would call content assimilation. This is the family of use cases that I alluded to a few minutes ago, where content is generated outside of the organization and then is obtained and collected, agglomerated, in order to gain specific insights. Now, this can vary from publicly available information collected around the world, but can also be obtained as a part of, say, forensic process, for example, scraped from a device like a laptop or a smartphone, or from service providers. It can also be data generated by a user community within an organization. So, for example, what financial institutions would do is monitor chat and email for compliance purposes and fraud detection. What's interesting about the content assimilation use case category is how widely applicable machine translation is here. And also how unpredictable the source content may be. So one day you're getting materials in Urdu and Pashto, the next day maybe Burmese or Khmer, and then tomorrow, Russian or Ukrainian. Additionally, this is a use case where large volumes of data need to be converted to insights very rapidly. So time to information is one of the main drivers. Now, the next use case category is communication and collaboration. So this is where you have teams and functions, individuals that work together across the language barrier, and they have to understand each other. It can be a desk agent type of work where you translate emails or documents, or it can be field work, like say a military exercise with NATO allies, or working to secure a logistics chain with the authorities of a host nation. Here, one of the main requirements is convenience. So the MT system needs to be fast, it needs to be easy to use, and handle a variety of different types of content. Say Word documents, PowerPoint slides, email messages, PDF documents, images, and so on. It may also need to be integrated with a variety of internal mission support systems, if you will. So these could be document repositories, tactical chat rooms, various intranet websites. It must also support large user communities. So you may have thousands of people having to communicate securely and in real time. And for some of those use cases, it's easy to see how impractical it would have been to add human translators or linguists. Now, the third content category, content dissemination or publication, is where machine translation was first deployed in support of a human translation effort. So as we discussed at the beginning, professional human linguists can produce high quality work, but there is a limit to their productivity. Every day they can translate maybe 1,500, 2,000 words. So in this use case, machine translation is often combined with translation memory and bilingual editors and other types of tools to help improve translators' productivity. In such workflows, source content can be run through machine translation first, then the human linguist will review it and post-edit the original translation if needed. And that's typically faster than translating from scratch. Now, those edits and corrections can also be captured, and that material will be used to improve the machine translation performance for similar content in the future, which is something Dragos is going to cover in a few minutes. Now, we've reviewed these three use case categories, and you've probably noticed that they have certain things in common, certain requirements that resonate within each of the use cases. So the first one is need for security, and that very often requires a private cloud or an on-premise deployment where your machine translation system and therefore the content that flows through it is completely isolated from the outside world. And that's because various organizations have their own requirements, the need for data residency, isolation, security, privacy, and so on. As a result, publicly available machine translation services often cannot be used because the risks run the whole gamut from litigation exposure, loss of intellectual property, to foreign intelligence interference, for example. The second element is speed or scalability of the translation process itself. And that's another important factor because, as we discussed before, government organizations often have very high throughput requirements. It's especially true for that content assimilation use case because data is gathered in real time from many external sources. And the insights need to be produced quickly in order to be useful. Some of that content may have very, very short shelf life. And this leads to the question of cost, including the cost of the infrastructure that one needs to scale the solution. So I may be able to afford a specific machine translation license, but if the platform requires extensive hardware and hardware that's sophisticated and expensive, like GPU-based servers, in order to achieve the speeds that I need, then perhaps those speeds are only theoretical because I cannot fit it within my budget. Similarly, even the best MT system is not going to be much use if I cannot integrate it into my workflow. This may entail incorporating human feedback in real time or APIs to hook it up to content repositories and analytics systems. Those needs go beyond pure translation. So for example, in many cases, you may need to identify the source language first. So a good MT platform should provide language and script detection capabilities. And finally, adaptability is another interesting factor. And when you think of it, I mean, when you're dealing with private content, then off-the-shelf machine translation models, which by definition are built on public data, may not be your best option, right? So there's a need for mechanisms by which the MT system can learn how to translate the content in question, the content to which it has never been exposed before. And in fact, since adaptability is quickly becoming a critical requirement, I'm not now going to ask Dragos to review the various strategies and mechanisms for improving translation outcomes.
Thank you, Bart. Indeed, these off-the-shelf generic models trained on publicly available data while they are good and we work hard to make them ever better, they may not be best at dealing with specific data domains. We therefore implemented capabilities that allow users to customize and adapt the models in various ways, and thus make them a better fit for their respective purpose and use cases. So let me walk you through the different capabilities that you see listed here on the slides. I'm going to start with dictionaries. Dictionaries allow machine translation users to enforce how specific words or phrases are translated. For instance, maybe there are certain technical terms that the generic empty model translates in a way that's not appropriate for the user's particular domain. Or maybe there are terms or phrases that should remain untranslated, should just be copied into the output. These are all good candidates for dictionary entries. In our product, users can create multiple dictionaries, and they can choose when to use any of them. Each individual translation request can be either via the user interface or via the API, can be configured to use no dictionary or one of specific existing dictionaries. The most effective way, though, to get a neural empty model to be a better fit for your particular domain is by customizing it, by training the model's parameter using data from that domain. I'm talking here about the statistical training algorithm that adjusts the many parameters of the neural network in just the right way so that the resulting network produces good translations. These adjustments are made by taking training examples, which are source language segments together with the desired translation in the target language, and adjusting parameter values so that the network's output is as close as possible to the desired translation. If properly trained, a custom neural model will learn various subtle aspects from the data. It will get better at producing the right terminology in context. It will also get better at reproducing let's call it the style of the training data, things like formality, active versus passive voice, and so on. RWS offers a customization service. Our team can take your data, process and clean it, and apply statistical training algorithms to produce a new model that is adapted to that data. And we leverage both our linguistic expertise for the data processing part and our machine learning expertise to produce the best training and also to do any follow-up investigations of specific remaining translation problems. However, in certain situations, again, as Bart alluded to before, customers cannot take advantage of this customization service due to security issues. They are not allowed to send the data outside their respective organization. So we distilled the best practices of the customization service and implemented a do-it-yourself version, which we call Adaptable LP. Now, Adaptable LPs are models that run in the locally deployed machine translation service. And customers can upload their translation memories, the training data, and on the click of a button, the model will be adapted to that data. And all of this happens within the local deployment. Besides the security aspects, this feature also gives customers quite a bit of flexibility, because from the same basic adaptable LP, it's possible to create several different adaptations, either because you want to experiment with different data sets or to use different models for different workflows or data domains. Another way for customers to interact with and improve our empty models is through real-time feedback. If a segment is translated poorly, users can provide a better translation right in our product's user interface. The translation is then fed back to the model, and the next time the same exact input is sent to the model, the desired translation will be produced. Clearly, this feature puts quite a bit of power in the hands of the feedback provider, because unlike dictionaries, which you can choose whether to use or not, feedback that is given to the system will be used all the time. So in an attempt to avoid mistakes, we provide a curation mechanism, allowing administrators to review each piece of feedback, and only approved feedback will be used by the model. Last but not least is the piece that tries to put together all of the above. So all adaptation approaches presented so far have certain downsides. For instance, adaptive LPs do produce better model, but they are static, right? You train the model once, it's done, it doesn't change anymore. As the organization maybe produces more data, if you want the data to be taken into account, the model needs to be retrained. You need to go again through the process of training a new model. Also, real-time feedback. It's great at producing immediate improvements, but it only works for those specific input segments that prompted the feedback in the first place. And if the input differs a little bit, the feedback is no longer taken into consideration. So auto-adaptive LPs solve these problems. An auto-adaptive LP is one that undergoes a continuous and transparent process of adaptation. The idea is that users just need to provide a steady stream of data, maybe by providing continuous feedback, maybe by uploading translation memories as they get updated, even dictionaries. All of this can be taken into account. And as more data becomes available, an auto-adaptive model keeps learning from that data in the same manner as an adapted LP, but it keeps doing it continuously and it keeps getting better without any additional user intervention. And the combination of all of these various data sources with the ongoing customization algorithm helps extract the most value from all the users' interaction with the system. And best of all, without requiring any specific effort from the same user. It all happens transparently behind the scenes.
Thank you, Dragos. This was very interesting. I like that we have so many different approaches and how they all come together with the auto-adaptive language pairs. And now, based on the different requirements that we discussed earlier today and the need to offer a flexible and adaptable solution for a variety of government and defense use cases, we designed our machine translation platform to fit in a variety of deployment models. So we offer a multi-tenant public cloud MT subscription. This could be used, say, for a municipal department somewhere, or somebody who's not working with perhaps very high volumes of data. We can also host a single tenant private cloud deployment. And then the third option is a fully secure, completely isolated on-premise machine translation system that the customers can bring and deploy within their own IT infrastructure. We support Kubernetes and Docker. We support virtual machines. You can also, of course, run it on physical hardware as well. Now, with either of those options or any of those options, the customers get an intuitive browser-based user interface, and that has both end user and administration functions. And a well-documented set of APIs, so in case you want to integrate Language Weaver into your own internal infrastructure. We also provide a bunch of out-of-the-box connectors. For example, we have a connector for Microsoft Word, for Outlook, for PowerPoint, for Excel, for popular web browsers, as well as specific translation management tools like CAT tools like RWS Trados Studio or Trados Enterprise. And since it's important for our customers to monitor the performance of their system, we also designed a reporting dashboard where you can track the MT usage per language, per user. And for the on-premise systems, we also have a monitoring console that provides real-time health data for the system. So now we are going to switch gears, and I'm going to show you a very quick demo of the system will translate some text, will work with, will translate a few documents, and I'll give you a general overview of the user interface. So I'll start by explaining to you how the translation works. First of all, I'm going to point out that we'll be inserting the source text or documents into the left-hand side box here, and the translations will appear on the other side. As you can see, if I knew what language I want to translate from, I have a whole selection. These are all the languages that are supported and part of this particular subscription. Altogether, we have about 146, I think, direct language pairs, and we can also translate between any of the combinations. So if you need to translate from Finnish to Hungarian, it'll work as well. So to make it interesting, I have a few copies of relatively recent material. I'll just copy paste just to give you an idea. So first bit of text from a newspaper article. So the system detected that this is Ukrainian and very quickly generated translation, even though it's never seen this content before. You can see if you read through it, it gives you all the right information, and it's written, the translation is structured well enough. It's fluent, you cannot really complain about it. But if I did want to make any change, I can actually say, you know, let's change this, suggest a better translation. And instead of saying, say, all market assets, I'll say all markets. That's not really what the source says, but for the sake of the argument, I think Rynkowe aktywy is assets, but I prefer this. So once I make this improvement, the feedback has been registered with the feedback database and can undergo a curation process, so that next time we translate something like that, the system will prefer the translation that was provided by the human. Now you can imagine that you could also express the expertise or convey the expertise that's non-linguistic. Maybe there's a term that is used in a particular domain that you know, you don't have to be a translator to understand that we call something a wrench rather than a spanner. So let's have a look at another example. That's another piece of text that we're going to translate. I'm going to use this example to point out a few technical life sciences related terms. You can see that there is even an acronym here, ARDS, which is converted from the French acronym SDRA, and correctly. The names of the different diseases have also been translated. And at the end, there's a name of a product that has been preserved, and the system didn't do anything about it. Now, so this is just another example of very quickly that we can obviously also handle text in scripts other than Cyrillic or Roman. So this is a Chinese text that is being translated. And as I inserted this text and the system recognized that this is Chinese to English, you can see that in addition to the generic model, another model popped up. This is a custom model that was developed using specific translation memories. And I can switch to that model, and the system will retranslate based on that model. So if you have material that requires special treatment for which generic models may not be adequate, as Dragos mentioned, you can build and deploy your own adapted language pairs for that purpose. All right, so this was translating text. Let's have a look at translating documents. So first of all, I'll show you my document here. So this is a little memo from the US Department of State about crossing the border into or out of Ukraine. You can see that this is a relatively well formatted document. There's the seal, there's some formatting here, colors, font properties, and so on. And it is in English, and I want to translate it into another language. So let's do Polish, since maybe we'll be crossing into Poland. And all I have to do with this document is just drag it over here, say translate to Polish. The system is going to extract the text from the document, translate it, and generate the target version of this document. So I'll open it now, and I'm going to show it to you side by side, so you can compare it to the original. And you can see that, of course, we have the Polish translation, Kryzys na Ukrainie. But that's not the only thing that happened here. The system preserved all the formatting, all the font properties, the images, the colors, the style. So I could perhaps just do some minor edits if necessary and send it off to wherever it needs to go. Now, of course, we can use the same mechanism for translating from other languages. And if we want to gain an insight, I'll show you a document that I have here. That is a PDF document. It's completely different structure. You can see this is looks like German, and it's a table with some line items. Looks like maybe an invoice or something like that. So I may not know what this document, what the language of this document is. So I'm just going to say detect language and just drag it just as well. It's detected that it's German, translate to English. What it's going to do for me, since PDF cannot really be easily edited, and I may want to make some changes later on, it's going to convert it into a Word document, and I can maximize it for you. You can see that this is some kind of sophisticated equipment that is being bought here and invoiced, but formatting, the structure of the table, the colors, again, are all preserved in the translated document, even though the original document was a PDF document and not a Word doc. So that's our sophisticated document handling capabilities in there. However, in many cases, what you want to use your translation for is to actually understand what the document is about rather than to publish it further out. And I have an example here of a report. This report is in Russian, and it was published on behalf of an international financial institution. And I want to know what this report is about. So I'm just going to drag it over here and have the machine translated into English. But as soon as the translation is done, I'm going to click this button next to it, the one with the eye icon, that's called Content Insights. What that's going to do is actually read the document for me and provide me with a summary of the document. So we use this mechanism called extractive summarization. And you can see that the most important salient points from the document have been extracted for me. And I have this noise to signal ratio input control that I can drag left and right to condense the extraction, the summarization, to just the points that are most important. And you can see that this is about the impacts of war on world economy. And I can copy this information and use it somewhere else. So that gives you an idea of what can be done with machine translation. We can use it for translating content in documents, in email. We can paste content from other sources. We can preserve the original formatting, but we can also use use it to gain insights about the material we are translating. Now, the last thing I wanted to show you is a little bit of administration. So I'll start by going to reports. So in this particular platform, in this account, we have a very generous subscription. So this demo user here is only scratching the surface of their subscription with less than 1% of the volume, because their subscription covers 20 billion characters a year, which is not unheard of. And I can monitor the sort of throughput on a monthly basis to see how much I'm using. But I can also create a custom report, and I can parameterize the report per date. I can pick the language pairs that I'm interested in, or maybe a particular user or set of users. Or if I have an integration, I can perhaps gain insights on how much volume is consumed for a particular API credential, which is basically a manifestation of another system coming in and using this machine translation service. We recently added a group functionality. So if you have multiple business units or teams within your organization, you can actually do that as well, and see how much each of them is consuming. Now, for the Language Weaver Edge platform, so that's the on-premise system, we have some additional administration functions, and I'm going to show you just two of them because I think they're very important from the point of view of the total cost of ownership and ease of maintenance. So the first thing that I'm showing here is managing the deployment for an on-premise version of Edge. And as you can see here, this system is running multiple different language pairs that the administrator can completely control. So I can turn them on and off. I can deploy additional language pairs if my license allows for it. I can take some of them offline. And this deployment, this instance, can be spread over multiple physical or virtual servers. You can see I have worker 1 and worker 2 and worker 3 with different functions assigned to them. There are translation engines, but there's also a training engine that can be used to create those adaptive language pairs that Dragos was talking about. You'll also note that some of my engines have one or more PUs. PU is a construct called processing unit. We actually use this as a way of meting out how quickly a particular engine should be able to translate, because your distribution of traffic across different languages may be different. Instead of buying an expensive license that can do 10,000 words per minute for all your languages, you can actually decide how you want to do it and have a more optimal type of investment. And in fact, that leads me to the second thing that I wanted to show you here. Under Entitlements tab, you can actually pre-assign how many processing units should be dedicated to a particular language. So basically what happens, as the system detects more traffic in that particular language, it will pick up those processing units from the pool and deploy them, so it'll scale automatically the speed, the performance of translation. And when all of this is happening completely automatically, without any administrative intervention, you can, of course, monitor the well-being of the system. We have this real-time console here that has hundreds of parameters that can be tracked. It'll show you the, how busy the machine is, how it is consuming the resources that are available to it, as well as things like, how many translation requests are coming, how many people are logged in, that sort of thing. So overall, the flexibility of the platforms that we provide allows you to build a machine translation workflow any way you want. You can integrate with other systems. You can translate text and you can translate documents. And you can empower the whole organization to use machine translation securely for a variety of different use cases. And I think we may be getting some questions.
Yes, we are. So let me direct this over to you guys. I've got a couple in here. Let me start off with the first question is, I have adaptable language pairs. What benefits do I get from auto adaptability?
Dragoș, do you
I
want
can
to
take that one?
Yeah, go ahead.
I can take that one. So I think there are two factors that determine which of the two solutions is best for a particular user. One is data availability, and the other is, let's say, the domains. So adaptable auto-adaptive language pairs are really useful if there is a continuous stream of data from which they can continuously learn and get better. If the organization is in a situation where there is an existing pool of data, but that's it, there's not more of it coming, then auto adaptation doesn't bring any benefit. The solution there is to use that to use adaptable LPs, train a model with the data, and keep using that. However, if you have users who like to interact with the system and provide feedback, and maybe more translation memories are forthcoming and so on, then auto adaptability can make use of all of these interactions in a very effective way. The other interesting point has to do with the domain. So as I mentioned earlier, you can train multiple adaptive LPs, right? If you have several domains that are distinct, you can train one adaptable LP for each of them explicitly, and you can manage them. An auto-adaptive LP, you cannot have several of them at the moment. So it would be only one. You can put all of your data from the multiple domain into it, and it will do the best it can, but it might be less optimal than specifically trained per domain adaptive LP. So I think those are the two factors that influence which one is best for a particular use case, whether there's a continuous stream of data or not, and whether there are multiple domains or not.
Okay, great. All right, thank you. Looks like we have another question. This one is, how fast can you translate, or what speeds can you achieve? Can one of you give us maybe some context on that?
Sure. Yes. So for the on-premise system, when you first buy it from us, each language pair comes with one processing unit. This is the concept that I described just a minute ago. And the processing unit, it corresponds to 2,000 words per minute. And what happens if you don't have more processing units? The translation requests will go to a queue, and as they get processed, they will be returned. So one way to plan is to understand how much volume you have, and you may know this ahead of time, knowing your use case, and you can say, well, we need 20,000 words per minute, and we can scale by simply adding processing units to the license. And of course, there's a hardware requirement. Fortunately, it's all the off-the-shelf hardware. You don't need to have any special supercomputers. What you need roughly to run at the 2,000 words per minute are 2 CPU cores. So if you had a server with 16 CPU cores, you could run 8,000 words per minute. Now, the biggest system that I know our customers deployed using this scaling method was about 600,000 words per minute, and that was for all the for all the languages that they deployed. They had maybe 10 languages there. So you can really almost completely linearly expand the capability of the system. Typically, it's done by adding multiple worker hosts on multiple servers, so that you can scale the system without actually stopping it. You can always add more of these units. For the cloud-based system, this is something we scale on our end, and we have a different mechanism, an auto-scaling mechanism, where the system detects peaks of demand, and it will automatically launch nodes of translation engines that will keep up the pace, and then when the demand subsides, they will automatically turn themselves off. So that's pretty much how it works. Again, there may be a bigger system somewhere that we deployed that I didn't work on, but 600,000 words per minute was the biggest I've seen.
Okay. Okay, it looks like we have another one in here. When should I use dictionaries versus real-time feedback?
I can take that one.
Okay.
So again, there are a couple of different considerations to think about. One is, what error are you trying to fix? If it's about a consistent mistranslation of a particular word or phrase, that's better suited for the dictionary, for the application of the dictionary. And as I mentioned earlier, particularly good applications are, specific terminology, or maybe terms that should be left untranslated. There are dangers in overusing the dictionary. For example, if let's say our system wrongly translates from English the month of May, and you decide to add a dictionary entry that translates May into that particular month in Russian, let's say, well, guess what? Every time the system sees May, as in I may do this, it will translate it as the month, and that's not what you want. So care has to be taken to identify really specific errors. So that's in terms of what error you're fixing. And yes, so dictionaries are good for specific words or phrases, whereas the feedback mechanism is better for full sentences, right? When there's a whole sentence that's badly translated, and maybe it's one that comes up commonly across your use case. Maybe it's I don't know, an email ending greeting or something. That's a very good example of where you would put the feedback. The other aspect, again, has to do with the fact that dictionaries are under the user's control. You can choose when to use it or not, whereas feedback, once it's been curated, is used by the system all the time. So if you want to make a change that should only take effect in a certain workflow, then you have to use a dictionary, because that's the only time when you can control what happens. But again, feedback can also be useful, more useful in terms of auto adaptation. If you do have an auto adaptive LP and you decide to use it, providing full sentence feedback helps the resulting auto adapted engine learn better, because there's more context in it. It can also learn from dictionaries, but due to the lack of context, there is less impact when you just give it dictionary entries. So yeah, I think those are the relevant aspects.
Okay, all right, great. So while you guys were talking, a use case came to mind. The US and the Korean armies have Language Weaver, and they've embedded it in a chat product that allows them to communicate with each other in their native languages. Could you maybe speak to that use case, as I think it represents another way to utilize MT for communication benefit, and there may be other use cases out there like that that possibly even the audience would think about as they kind of consider their own businesses.
Sure, you could use this for this use case. We in fact have that kind of request quite often. We can even customize the look and feel of the user interface if you want to expose some of it to the end users, so that it'll look like the part of the agency's infrastructure. Or you could just use an API based integration and use the business logic of the web app or the web website that you're integrating with. Either of those worked. We've done this in the past, both for government agencies and commercial customers.
Okay, great. Thank you. Well, I think we're coming close to the end now, and I just wanted to kind of wrap up to thank both Bart and Dragos for some very interesting and insightful and educational information for myself as well. I would recommend that if people want to learn more, that they can go out to languageweaver.com. And if we didn't get to your question, we will follow up post the webinar directly with you to provide a response. And if you have questions that maybe you didn't want answered in front of everyone, you can send us a message at askyourgovexpert@rws.com, and we'll get a response back out to you. And with that, I'd like to thank everyone who joined today, and again, thank our presenters, and wish you all to have a good afternoon. Thank you very much.
Thank you.
Thank you, everyone.